Hello. As we continue on with Chapter 10, we've already talked a lot about the hippocampus, and so now we're going to go on and talk about some other areas that are involved in memory. We've touched on a few, but I just want to make sure we're understanding that the hippocampus isn't the only part of the brain that's involved in memory. So again, we're just going to mention some other subcortical brain areas as well as cortical areas that are also important in learning and memory. So when we talked about the amygdala early in the semester, remember the amygdala sits really close here to the hippocampus in that temporal lobe. Now, do you remember what we kind of said we should associate with the amygdala? Fear, emotional memories, those types of things. And so fear learning is something that the amygdala plays a significant role in, although other areas may also play a role. But when we are conditioning an animal to fear something like we play a tone and we electrify the grid, giving them a foot shock, they learn to avoid that. They fear it, right? And so they'll avoid going to get food to avoid that shock. And it's a little bit more complicated than we have time to go into here, with the amygdala having subdivisions that seem to play different roles in this conditioning and the extinction of fear-related behaviors. We'll talk a little bit more about the amygdala in other areas of the class. And one line of research suggests that the amygdala may just facilitate consolidation of the fear memory in other brain regions as well. Then we have the parietal lobe. So the parietal lobe pieces together information from different senses. So people with damage to the parietal lobe seem to be kind of devoid of episodic memories, but if they're asked a specific question, they can answer them. So the left parietal lobe seems to be important for verbal information, where the right would be more nonverbal information. So parietal lobe playing an important role in verbal short-term memory. So remember, so far, all the areas that we've talked about, semantic memory stays intact, but damage to the anterior and inferior temporal lobe does cause semantic dementia, or the loss of semantic memory. It needs to be bilateral, or in both hemispheres, for it to really impair the semantic memory. And while it's not listed here on the slide, there are parts of the prefrontal cortex that are important in learning about rewards and punishments. The amygdala kind of has these two projections to different areas of the brain that may play a role in that. The basal ganglia and dopamine are also involved in the reward system, which is a way of learning. And we'll talk a little bit about that in some subsequent videos.